Patch 10.9. A brand
wish I could remember it, but it's been a while since everything was okay.
Good morning, everyone. Good morning, Joe. Good morning, Olivia. And good morning, Angel. And 3 other people who are here. Aaron, good morning. We're just waiting on people to come in. Got 7 people here. Once again, we're going to wait around 3-4 minutes and then we're going to get started. We're going to be taking up the some of the questions from the practice worksheet. So not everything that I circled or that I asked people to do from yesterday's homework assignment. So this one, we're just going to take up a couple and then we're going to move to today's lesson, do a couple practice problems, and that'll be it for today. Okay. Good morning, Nathan. I look a little tired. Maybe. Who knows? It is Wednesday. We are halfway through the week. I even forgot that it's Wednesday. I started losing track. I started losing track of time. And yesterday I thought it was Wednesday, but it's really not Wednesday. And today's Wednesday. It's crazy. Yeah. Things get way too crazy, time-wise. Good morning, Amir. Good morning. Okay, it is 11:05, so let's get started with our things today. Did you like Mr. Booth, Amir? Okay. He was definitely a very wise man, I gotta agree. He's very fun to talk to. Okay. So this is the homework that I asked you to complete, right? So let's take over some of these, take up some of these questions. Let's kind of do two from here. We'll take a couple of the harder ones, and then we'll take one easy, one hard, and then we'll keep going from there. So this first one here, or no, we'll do the second one because we have a little more space to work with. So for the second one here, we have x plus 8 times x plus 1. So when we follow FOIL, remember that FOIL stands for first, then outside, then inside, then last. So we're going to take our first terms, we're going to multiply them together. So x times x, that's going to give me x squared. Then we multiply x times 1, which is just 1x, or just x, positive x. Then we do 8 times x, which is plus 8x. And then we do 8 times 1, which is positive 8. Once we have multiplied it out, we can now combine our like terms. And once we combine our like terms, we get x squared plus 9x plus 8. Okay, well, give me 1 second, guys. Okay. So, there's one question done there. Let's go to our next one down here for h. 4 plus 2a times 3 plus 2a. Following FOIL, 4 times 3 is 12. 4 times 2a gives me 8a. Then 2a times 3 is 6a. And then 2a times 2a is 4a squared. Okay. Once we have that, we can combine like terms, and we should get 12 plus 4a plus 14a plus 4a squared. Now, some of you might be thinking like, is it okay if like the a's on the second term, whatever it is? Yeah, absolutely. It doesn't matter where the variable is. A binomial is just two different terms. So you should be able to multiply binomials even if I give you different variables or multiple variables that you can write out. Okay? For this one here, I'm only going to do 2a, which is the trinomial expression. Okay? So make sure you understand how to do this. A trinomial expression is just saying that there's three terms in your answer, as there should be. For example, when we multiply our binomials, we get three terms. This is a trinomial. Can we do 4a squared plus 14a plus 12? Absolutely. You can rewrite this, and making sure that the 4a squared is at the front. If you can rearrange it, that's completely correct. So very good. Good question. Yes, the order doesn't matter. And if you can reorganize it like this might actually help some of you. So this is a trinomial here. There's three different terms, and that's kind of what we're looking for here. And if you remember the area of a court, right? Area is just length times width. We know that. And from here, we can say that the length is x plus 1, and the width is x minus 11. Okay? Because we can see here, this is the length, the longer side, and width is here, the shorter side. So when we do it, a is equal to length, which is x plus 1, times width, x minus 11. So you set up your brackets. Notice how I have to put brackets, because the length is this whole binomial. It's not just the 1, or it's not just the x. And since we're multiplying the length, it has to multiply the whole thing. That's why we put brackets around it. When you substitute, we use brackets. Same thing here. We're going to do that, and we're going to multiply it. When we multiply this out, we get x squared minus 11x plus x minus 11, which should end up as your final answer of x squared minus 10x minus 11. And there's our final answer there. Okay? So hopefully that made sense. And of course, I'm not going to do part B because in case some people are handing it in a little late, I do want to give them some time to hand it in and complete the work. Okay? So, that being said, let's move on. Whoa, this is not the one. Oh, yes, it is. Not this page. So, question 4. Right, I asked you to do a couple of these. These were special products. Okay? So, let's do a couple of these with special products. Let's do this one here. 7 minus a squared. So if you ever see like it's written out like this, you should immediately know, hey, that's a special square. Like that's a special product, right? So because it's a minus b squared, right? We're going to get our final answer here. Right? Well, let's do this. Let's write it out here. Okay? We get a squared minus 2ab plus b squared. Right? Now the confusing part about this is that a is 7 and b is a, which is a little odd, but let's work it out. If you use the formula correctly here, plugging it in, you should get 7 squared minus 2 times 7 times a plus a squared. So that's what we should be plugging in for this special product here. Okay? For our special product, 7 squared minus 2 times 7 times a plus a squared. That's going to give me 49 minus 14a plus a squared. and there's our answer. That's it. Now, if you wanted to rearrange it and you did a squared minus 14a plus 49, that is also correct. Okay, so let's cover both bases here. So once again, if you have that there, okay. And then our last one here, we'll go down here for L, 2x plus 2y, 2x minus 2y. So this, the terms are the same, right? A plus b, a minus b. So this we know is a squared minus b squared as our answer. So we know that a is 2x and b is 2y. So when we plug it in, we get 2x to the power of 2, minus, not plus, 2y to the power of 2, and we can expand that. We get 4x squared minus 4y squared, because 2x squared is 2x times 2x, so 2 times 2 is 4, and then x times x is x squared, and then for 2y squared, 2 times 2 is 4, y times y is y squared, and then we get our answer there. Is there any other question that you would like me to go over for this page or the previous one? Are there any questions? Let's get one or two more if anyone has any suggestions. Otherwise, we'll move on to today's lesson. Alright, type a G in the chat if you're good, because I need to know whether you're good or not. I'm still kind of waiting for people to let me know. Okay, so I think we're gonna move on then. Let's move on. Okay. Our new worksheet for today. If you don't have this prepared, please go print it out. It's Unit 4, Lesson 3, Common Factoring. So if you don't have this printed out, go print it out right now. I did upload it this morning. Okay. So please go have this prepared right now. And then we will get started. So I'm going to give around 1 or 2 minutes for people to get this prepared. And then once you're prepared, and then we'll get started. Okay. So, GCF. This is not a new concept for you guys. GCF is definitely not a new concept for you guys. This is something you've done before, and we're just kind of now taking it into context of using variables. You've always used GCF with fractions or multiplying stuff, and like we talked like dividing stuff. And you always just use numbers. But you have to also remember that since variables are technically numbers you just don't know, you can use it for variables too. So, greatest common factor, GCF. Okay. Greatest common factor. Well, that factor, that should be a C there. Sorry. So greatest common factor is the largest, or if you want to say biggest, you can say biggest, factor you can divide all terms. All is very important. This is a key word here. All is very, very important. Has to be all terms in a polynomial. Okay. So once again, GCF is the greatest common factor, and it's the largest factor you can divide all the terms in a polynomial, and it has to be all. If it's not all, it's not a greatest common factor. You can't divide it. Okay, so this factor can be a number, right? Which could be, for like, we'll do some examples here on the side, a variable, or number and variable. So for example, a number could be 5, a variable could be like x squared, and a number and a variable could be something like 2xy, right? So we can always kind of just divide things, but we have to make sure that it's divisible into everything. And I'm going to show you a simple way of how to kind of determine that real quick. Okay? So I'm going to try to show you a very quick way, or a faster way you can kind of solve these questions and find the greatest common factor. Once again, this unit is building skills for the next unit, and you'll see how we apply these in Unit 5. And Unit 5 is the important one, right? The very important one. And this is like the build up to the really important one, so this is also really important. So, find the greatest common factor of 12 and 9. Okay, greatest common factor of 12 and 9. So what's divisible into 12? What's divisible into 9? Right? So we can make it very easy and simple. Like, we can list all the factors, right? If you really wanted to. You can list all the factors for each one, right? And then you'd say, oh, what's in common? Oh, 3 is in common. So that is the greatest common factor, right? It's a factor that's common in both of them, and it's the largest one, right? 1 wouldn't be a greatest common factor because it's 1. And it's the lower one. For 4 and 6, you can list it out, but if you already know, you can just write out the answer, right? So 4 is 1, 2, 4. 6 is 1, 2, 3, 6. Right? So the greatest common factor here would be 2. So hopefully we're understanding here, right? You're thinking, what can I divide 4 by? What can I divide 6 by? And what's the biggest number that divides into both of these? Okay? So if you have to list it out, you can list it out, right? So if you are able to do that, you should do it. If you're not as good, use a calculator, right? Try to figure out what can I divide by, and when I divide by, what gives me whole numbers. But then we come to this issue with x squared and x cubed. How do you do that, Mr. Choi? Well, I'm happy that you asked. Well, x squared and x cubed here. Okay, x squared and x cubed. When you're working with variables, there's a very simple and easy way to get the greatest common factor. You look for the lowest exponent. That's it. The lowest exponent is what you're looking for. So for x squared and x cubed, which one's the lower number? 2. So the greatest common factor is x squared. That's it. Very simple. We'll look at some examples for that. Okay? We'll look at some examples for that. Now, what if we have to do a combination of everything, right? Then we'll look into those combinations. All right? So, let's look at example 1 here. Step 1, find the GCF. Find the GCF. All right, let's do it. Let's look at only the numbers first. So 3, 6, and 36, right? Well, we are going to look at the number that has the least amount of factors. For us, it's 3. 3 only has 2 factors, 1 and 3. We don't use 1 as a factor, so which means it's 3. See what I'm doing there? So we look at the smallest number because that has the least amount of factors, which is going to narrow down what factors I can use. So I'm going to look at 3, and since 3 is the factor I can use, is 6 divisible by 3? Yes. Is 36 divisible by 3? Yes. So 3 must be the greatest common factor. Okay, so GCF is 3. Okay, GCF is 3. So what we're going to do now, we are essentially saying I'm going to take out the 3 and I'm going to put it in front of my polynomial. I'm going to take out the 3. I'm going to write it down here. Then I'm going to write a bracket. And this is where the new stuff comes in. Now, before we get into that, when we look at the variables, because we do need to think, is there a variable we need to pull out? The reason why we can't touch it is because is a variable present in all of the terms? No. There's an x squared here, there's an x here, but this doesn't have an x, which means we cannot pull out an x. It's not part of the GCF. Okay? Everything has to have an x if you want to pull it out. Okay, so it doesn't have an x, we can't pull it out. So we're going to keep going here. What we're going to do, we're going to take the 3 and we're going to divide every single term by 3. So 3 divided by 3 is 1. So 1x squared, or just x squared. Then we go to the next one. 6 divided by 3 gives me positive 2. So plus 2x. Negative 36 divided by 3 gives me negative 12. And there's my answer. And that's it. Okay? So that's how we do our GCF. And of course, step 3 is to check the solution by expanding. If you multiply the number in front into the polynomial, right? 3 times x squared gives you 3x squared. 3 times 2x is 6x, so on and so forth. You should get your number back. Yes, we get 3x squared plus 6x minus 36, which means it's correct. Okay? So that's how you check your work. Let's do our second one here. Okay? So same idea. Let's find the GCF. So GCF is, work with the number first. The lowest number of this group is 5. What are the factors of 5? Oh, it's 1 and 5. We don't use 1, which means we have to check if 5 works. So 5 is divisible by 5. That's good. 15 is divisible by 5. Yes. 35 is divisible by 5. Yes. So definitely 5 is a greatest common factor. But we're not done just yet. Does every term have an x? That has an x. That has an x. That has an x. So we know that now we can say x is a factor, a greatest common factor. And to take out the greatest common factor for variables, I said, look at the x with the lowest exponent. The smallest exponent is what you're going to take out. So there's a 5, there's a 3, and there's a 4, which means the smallest one is x to the power of 3. So we just take out and say that's the greatest common factor. Okay, so the number and then the lowest exponent variable as long as all the terms have it. Okay, so we take out the 5x cubed. We're going to write it out here. And then now we're going to divide it. So 5 divided by 5 is 1. That's good. X to the 5 divided by x to the 3. And you're all going, I have no idea what are you supposed to do. Very simple. Just subtract the exponents. So 5 minus 3, 2. So it's x squared. Okay. The next one, 15 divided by 5 is 3. So we write the 3. And x cubed, subtract x, so x cubed divided by x cubed is just 3 minus 3, which is 0. It's gone. So we don't write it. The next one, negative 35 divided by 5 is negative 7. And then x to the 4 divided by x to the 3. 4 minus 3 is 1. So it's just x. And there's our answer. If we wanted to reorganize that in order of highest to lowest exponent, it would look something like this. And to check your work, if you multiply it out, you should get the same answer, which we do. Okay? All right. So are there any questions on this here, this content here? So GCF, all you have to do is get used to it, right? How do I, find the factor? Find the factor first. Do I understand how to find the factor? Then the second step, is the variable divisible? If so, what's the lowest exponent? Pull it out. Okay, now let's divide everything. Divide the numbers. Divide the variables. What's my result? And then you get your final answer that way. Okay? So it's, once again, just takes time to get used to it and solve it, so on and so forth. Let's go to example 3. Our last example, and then we go to our worksheet for today. Factor 2a bracket 2 plus a minus 3 bracket 2 plus a. Okay? And it says, note, you can also have a binomial as a GCF. So here, your first instinct is probably, I should multiply the brackets and then factor. You can do that. But you'll notice, aren't the brackets exactly the same? 2 plus a and 2 plus a. They're present in both, which means this must be a GCF. So we can say that the GCF is 2 plus a because, well, that's repeating. It's there in both terms. So we don't have to multiply any brackets. So what happens here, this is a very unique case. We're going to say, I'm going to take the 2 plus a, I'm going to pull it out. And then that's going to cancel these 2 plus a's here. It's gone. So your second bracket is just going to be what's left over, which is 2a minus 3. And you're done. That's it. So if you notice that there's a bracket present in both of the terms, you pull out the bracket, you cross the bracket out, and you see, what's left over? And that'll be your second bracket. Okay? So this is a special case that you'll notice. Okay? Now for those who are wondering, Mr. Choi, that's confusing. Can I just do it the other way and just expand the bracket and do that? Yes, but not now. You're going to learn that tomorrow. Okay? So you got to have a little bit of patience here. So if you ever see this method, this is the fastest way of doing this, right? If you see the brackets are the same, pull it out. That's your greatest common factor. Okay? So ta-da! Alright, so we got a whole bunch of factoring stuff. You'll notice worksheet 1, the left side should take 10 minutes. Worksheet 2, the right side should take 20 minutes. Let's take a couple of these questions. Once again, just greatest common factor stuff. Okay, so let's pick 2, 3, and 6. Something like that. Okay, 2, 3, and 6. So let's do 2, 3, and 6. Let's zoom in so we can see it a little better. So, same idea. Here, what's my GCF? Let's write that GCF down first. So my GCF for the number, what's my lowest number? My lowest number here is 5. What are the factors of 5? Factors of 5 are 1 and 5. So if 1 and 5 are my factors, I can't use 1, so I'm going to check, are the other numbers divisible by 5? 35, yes, you can divide by 5. 60, yes, you can divide by 5. So when we divide these by 5, 35 divided by 5 and 60 divided by 5, we should get our answer. So we know that GCF is 5. For x squared, x, nothing. Which means, since this doesn't have an x, we can't pull out an x. So x is not part of the GCF. So the GCF is just 5. So we're going to write the 5, bracket, and then we're going to go through and divide everything by 5. So 5x squared, so 5 divided by 5 is 1, x squared stays. 35 divided by 5 is positive 7, and the x stays. 60 divided by 5 is 12, and there's nothing else there, so there's our answer. Okay? There's our answer. So let's make you do question 3 on your own. Actually, let's do questions 3 and 6 on your own. I'll give you 3 minutes. We'll say 3 minutes. I think 3 minutes is enough time. So let's do 3 minutes on the clock. Sorry, 1 second. Just gotta move this over for a quick second to set this up. 3 minutes. Timer is on the screen. Good luck. Time is up. Okay, let's take this up. These two here. Looking here, what's the smallest number in front? 1. Do we factor ones? Nope. Which means GCF is not a number in this case. It's just 1, so we don't really write that down. Do all of them have x's? Yes. What's the smallest exponent of x? 1, which is just the x, which means the GCF is just x. So we're going to pull out an x, and then we're going to divide all of them by x. So when we divide, we just subtract. 3 minus 1 is 2. Write the number down because we're not changing the number. 2 minus 1 is 1. And the last one, 1 minus 1 is 0, which means it's gone. And that should be your answer for number 3. For number 6, similar idea. Number 6 is a similar idea. Okay. Number, there's a 1, so we can't pull out a number. P's, does everything have a P? Yes. What's the smallest P? Well, P to the power of 1. What about Q? Does everything have a Q? No. Everything does not have a Q. This one's missing a Q, which means the GCF is just the variable P. So we're going to pull the P out. And then we're going to divide. So 3 minus 1 is P squared. Minus 3. 2 minus 1 is P. And the Q, we didn't touch it, so it stays. Don't get rid of the Q. The Q doesn't disappear. Then minus 4, P minus P. 1 minus 1 is 0. So what's left over? Q squared. And there's our final answer there. Okay? So hopefully you got that right so far. If you got that right, amazing job. You are on the right track of getting greatest common factors and doing all of this. If you didn't, please make sure you look at the rest of this page and practice it. Right? Practice, practice, practice. If you want me to check your work, just send me an email saying, hey, Mr. Choi, this is my work. I'm not sure if it's right. Can you double check for me? Right? Send me an email, post your photo, and I'll take a look. Right? So you need to be able to upload that for me. So let's go to this side here. It's all, once again, more greatest common factor stuff. But what's important is this one. Let's do number 9. Okay, I'm going to give you a quick minute to do number 9. I'm going to give you 1 minute. Try to find the common factor for this one. 1 minute. All right. Hopefully you are done by now. You should notice, oh, hey, the brackets are the same, which means the GCF is that bracket. Hopefully you started with that and exactly in that voice that I just did. And if you did that, then you should get a plus 2 in the bracket at front. And then we cross them out to help ourselves out. And we say, what's left over? Oh, I see 2 plus 7a, which means that's my second bracket. And you're done. That's it. Make sure you do number 10 though. Number 10 is a little tricky. There's like one small trick there, but hopefully you can get that one as well, right? But otherwise, that is it for today. Your homework is to finish the rest of this worksheet, and we will continue on with some new factoring stuff tomorrow. Okay, new factoring stuff tomorrow. So make sure you complete all of this work. Okay, should take you less than 30 minutes now because we did some of it already. So I will see you tomorrow. I will most likely have office hours on Friday for your class. And be on the lookout for a possible quiz early next week. And that should be good. So yeah. So I think I might do the quiz maybe either Monday or Tuesday, depending on like how I feel, on whether I feel you're ready or the things I want to talk about. So yeah, so I think that'll be good. All right. So otherwise, have yourselves a good rest of the day. All right. Make sure you finish the homework. I'll cover a few more practice. I'll take up some of these questions tomorrow so that you have some answers to work with. But otherwise, have a good rest of the day. I will see you tomorrow. Peace out.